Right, without my glasses. Hi, thank you very much for being here. Really excited about this panel. I'm pretty new to the ThinkBox team. I've been at AWS for a little over a year, but just joined the team about 2 weeks ago. But my background's pretty heavy in media and entertainment, having been CTO at Lucasfilm, years at Apple, and prior to that at Alias Wavefront. GPU rendering and the stuff that's taking place with GPU in the cloud is a really hot topic these days. And so we're really excited to have some real prominent leaders here with us to talk about that. We've got representation from, well, my slides are advancing. Hang on one second. Aha. So from Autodesk, the Arnold renderer, from Otoy and Redshift, and a little bit about each one of these. So Arnold renderer is a really interesting topic for us here today because it's traditionally CPU. They announced not that long ago that they were going to start moving to GPU or start supporting the GPU renderer. But you can see by these spectacular images by some of their customers, and one that I know really well, they've been doing some great work in the CPU land, and we're really excited to hear what their experience is in moving to GPU. And so with us today, we have Tiago Is, who is a principal software engineer at Autodesk, focusing on this project, leading this project, I believe. And so we're very interested to hear what their experience has been like. Next up, we have a company that has been doing GPU rendering for quite a while, leading the edge from both capture all the way through to rendering and output, and doing some pretty amazing stuff along the way. I think one of the first people I had ever met that was completely dedicated to GPU rendering. With that, we have Jules Arbach, who is the founder of Otoy. Been doing for 25 years, it says, really. When was there? Well, we'll get to that in a little bit. But we go way back in talking about stuff that we tried doing with them years ago when we were both on a panel. Next up is another company doing some very interesting things in the GPU space. You've probably seen some of these images around. Very excited by the kind of work that they're doing in film and TV and the amount of tools that they have available for the production studio for GPU. And with that, we have Nicholas Burtnick, who is one of the co-founders of Redshift. Nicholas has been doing this stuff for quite a while. He was actually on the research team at Alias way back when, working with somebody that we know well, Bill Buxton. And now is driving their technology team for GPU rendering with Redshift. So we've got a number of topics here that we're going to talk about, some of these high-level topics here. And we really want to focus on the technology and the infrastructure of what's taking place for them with this new migration, both to GPU and then GPU to cloud. So I've got a number of topics here, and I'm going to start off by asking some questions with regards to what do they see as rendering in the cloud sense from a media and entertainment, and how to balance that complexity and efficiency? Something that's traditionally been something in the CPU world, but I'd love to hear from you about what's taking place in GPU, what's taking place with cloud, and how that's going. And I'll open it up to any of you to start. Jules.
All right, I'll start. Our software, Octane renderer, came out in 2010. It was a GPU-only unbiased path tracer. And there's never been a CPU version of Octane or Redshift. And so we've always been in the GPU world. And we started off, not really ready for production work, but really it was used for architectural visualization. And it was very clear that GPUs weren't just faster than CPUs, but they could also scale better. So you could put 4 GPUs, get 4 times the power in your motherboard, and that could still be on one box, and you just didn't have that many sockets on a motherboard. So as we built new versions of Octane every couple of years, we added animation, and then we're now at the point where Octane 3 was used to do the opening of Westworld and a lot of other great TV shows. We're seeing some work now being done 4K per eye in films. So we had a feature film that came out that was done in Octane on the cloud partially. And I think that the future for GPU rendering looks really bright, because a lot of the media that's coming down the line is VR rendering and holographic rendering, and these things just push the amount of rays and the amount of surface area that you need to cover by orders of magnitude. And so a lot of the reasons why we started a cloud service on AWS a few years back was to handle giant VR rendering workloads, and we built that. and we've had a lot of data from that kind of system being in place. So I think that the GPU rendering is in a pretty good place. We're seeing a lot of traditional CPU renderers move to GPU, so I think it's been really well validated. And I think that the future beyond films is where GPUs are really going to shine.
Tiago, I'd love to hear from your perspective, being a traditional in the CPU rendering. Did the customer request drive your decision to start going GPU and want to get more done? I mean, I'd love to hear a little bit about that experience.
Right, so I guess for some history, Arnold started off, decades ago, focusing on the really high-level film. And so there, everything was, massive, lots of memory. GPUs back then wouldn't really make sense. You just couldn't fit that scene on a tiny little GPU. It's a gigabyte of memory or whatever. That's changing. So memory's going up on GPUs, enough that now it's becoming practical. Also, now that we're part of Autodesk, we also have, a way bigger client base. And a lot of people who are, not rendering giant feature films, but smaller, interesting things like a commercial or things that can fit on a GPU, on a present day or last year's GPU just fine, as these guys will attest, I'm sure. And so that was, I think, a big driving factor is, hey, now we have customers that want it and can use it.
Very cool. And Nicholas, from your perspective, you have one of the most complete set of tools for production for GPU, and love to hear, I know we were talking a little bit about this offline, that decision that a customer makes between the complexity of what their shot is and balancing that with the efficiency in their budget, how is that changing with your migration to things to the cloud, and what do you see happening there?
Well, one of the biggest challenges we have when we talk to customers is getting them to get over their preconceptions about what a GPU can and can't do. Some of the things that Tiago brought up are true. The GPUs tend to have less available memory, but there are ways you can deal with that. And we came out of the gate with like out of core access to geometry and textures to sort of mitigate that problem. So like instead of your scene just aborting the render because it's out of memory, we're sort of using the onboard VRAM as a cache. And you do take a bit of a performance hit, so it's not something you want to do all the time, but it does give you an opportunity to render that scene, if you're just sort of hitting that memory limit. But basically what we saw is like GPU is kind of like it democratizes rendering in a sense, like a single artist, a hobbyist, all of a sudden, they throw in 4 gaming grade graphics cards, spend a couple $1,000s on graphics cards, and they've got the equivalent power of 20 to 40 CPU nodes, and that was a big deal 5 years ago, and it continues to be a big deal. And to me, the cloud kind of like is an extension of that. So, you don't need to have the huge capex of buying a gazillion machines and GPUs. If you can take this big project and just burst out to the cloud if necessary, if you need to. And we actually are seeing also studios sort of going the next step and saying, well, we're sort of going to have almost no capacity on premise, and we're going to build all our capacity on the cloud. So whether it continues to go in that direction, I guess it depends a lot on the economics of it. But yeah, we'll see.
Very interesting. Cool. So I know Tiago and I were talking about this particular topic about recent breakthroughs taking place in rendering, and the question was, do you mean CPU or GPU? And I think it's a great point to start there as far as what recent advancements have been made on CPU that you want to see happen to GPU. And then for the other two guys, I'd love to hear about the GPU advancements that have been taking place, or what do you want to see be taking place?
Right, so advances on the CPU. There haven't been too many advances in many years that really excite me. There's AVX2 and 16, but we still don't use that. We're still on SSE4 because we still have to support customers on ancient hardware. So it isn't actually that exciting on the CPU world. On the GPU world, it's a lot more exciting, and there's constant advances. The NVLink is a really neat one, because it means that, hey, okay, fine, GPUs are still tiny, but if you can get a bunch of them, they're pricey, but if you can get a bunch of them, now you can fit it inside the conglomerate of GPUs. Another interesting one is the so the tensor cores, which tend to be used for machine learning. That's produced some really interesting stuff in the last year. For example, NVIDIA has AI denoising, which is super fast. We're talking like milliseconds. And you get a pretty nice denoised image. It's great for interactive, lighting situations.
Cool.
Following right off of that, we also think that AI on the GPU is fascinating. So I think all of us are looking at optics, which is NVIDIA's built-in denoising solution. I think many of these renders also, including us, we have a second denoising option, and this one we built ourselves on CUDA NN. And it's designed to take a little bit longer than optics, but it does do really clean final quality denoising for volumetrics and for non-volumetrics, and it's really impressive to see how well this works. We were trying to use the tensor cores on the Voltas, and unfortunately, not all of those things mapped, even on optics. So I think there's more work that NVIDIA can do, but the fact that there's even AI hardware stuff going into Volta and future cards, I think is really interesting, and that could really help speed up denoising and even parts of rendering, I think, in the future.
Awesome. Anything to add?
I mean, yeah, I agree with everything Jules said, and maybe, who knows, maybe they'll have other tricks up their sleeves for accelerating other aspects of rendering.
Yeah.
Cool. Well, this next one, back when I was at Lucasfilm, 2009 and 10, we started experimenting with some GPU rendering, and we did our first actual simulation of some fire for a Harry Potter film. And I know there was a lot of trepidation and concern and timeline budgets and everything. Could we take this experiment? Would it disrupt anything? And fortunately, it proved out to be very advantageous, and the results were great, but not without a lot of experimenting along the way. Now, as we see it more and more happening, I'm interested to make sure. Okay. I'm interested to know if we can get that feedback to just rock. To know about, are you hearing from your customers more and more that the idea of doing an entire production and just completely GPU, or, and what benefits does that give them for complexity, things like that? More of an open question. I mean, Nicholas, why don't we start with you on this one, going down.
Sorry, I was a little bit distracted.
Distracted? Oh, that's why I was calling it, yeah. The idea of the viability of GPU rendering for VFX Studios. I know that we're still transitioning from the perception of CPU to GPU, and some have really jumped in, and then others are still a little hesitant. So I'd love to hear from your customer base.
So there's definitely been a lot of trepidation by the larger VFX studios of sort of taking the GPU leap, but we actually are seeing significant movement in that area. So I think the most recent project I can talk about is Rampage. All the VFX on Rampage were done with Redshift, and that's kind of a big step for us. We started out with mostly hobbyists at first, and a lot of small studios doing advertising and stuff like that, and then sort of like animation for children's cartoons and the like became kind of our bread and butter. But we're definitely seeing movement into the larger features, either feature-length animation or like high-end VFX. So,
and for all of you guys, what do you think is driving that? Is it that they get more iterations from the speed? They get therefore creativity?
So iteration time is massive. I know, like when we talked to Blizzard, this is not VFX specifically, but Blizzard, did all the Overwatch cinematics with Redshift, and apart from the fact that they're spending so much less money on hardware to do the job than they would have otherwise with their RenderMan pipeline, they're saying that they're actually they're able to use much smaller teams. So they're saving on person hours as well, which is a lot more expensive than a box. So yeah.
Very cool. And anything to add, you guys?
Yeah. But one interesting thing is, even right now, so I still think that a single GPU might not have enough RAM for rendering some of the complex shots that we see in visual effects, but it could still be useful right now for like interactive lighting. So you just have a subset of the scene, you're moving it around all nice and quick, and then you send it off to the farm, and it renders with the whole scene on the CPU, or possibly on a bunch of GPUs with NVLink.
one thing that is, and NVLink is, I mean, I think the reason NVIDIA added that was so that, because I had brought up for years, like you need 128 gigs of RAM for typical, scenes, and the GPU has 8, 16, maybe 32 now. And with NVLink, yeah, you can sort of get to 128 or 256 gigs. But Redshift, I mean, as you guys were saying, when you launched, you had out-of-core geometry working. So any shot in Redshift on the GPU was able to render. I think in V-Ray they have a CPU fallback, so that if it goes out of VRAM, it defaults to the CPU version. We recently got geometry out of core working in Octane 4, which we're releasing this year. But NVLink is probably the best no compromise GPU memory solution. But I do think that it is possible to leverage out of core geometry in different ways and still get GPU power. And I think that is still better than CPU rendering, in our opinion, with everything in memory.
Yeah, it might work sometimes for sure.
I always wonder if there's maybe more work that can be done in clever ways of automatically simplifying the scene, basically doing things to reduce the amount of memory you need. So having an efficient representation for your scene data is one thing, and Arnold does a good job. I'm sure Otoy does a good job of that. We try to do a great job of that too. But that only gets you so far. If you have a trillion unique polygons, that's a lot of data. But there's got to be ways to. I mean, you only have so many pixels on the screen. You don't need a million triangles per pixel to get detail. So there's got to be ways to sort of not store all that data.
Yeah.
Well, it brings up a great subject of the GPU availability in the cloud, and for VFX and other. I know that the idea of using it for light field rendering and using it for a lot of other things. Now, this capability of being able to burst into a massive amount of GPUs when you need it. How do you see that starting to change the business model, and what do you see as both positive and challenges? I wouldn't say it's negative, but challenges that you'll see around that.
Yeah, I think from our perspective, having launched a cloud service for VR renders, and all of our light field, people are familiar with the light field renders we've done. Those have all been done on AWS because those jobs could be they could be thousands of dollars on AWS, but that's the amount of GPU power needed to do this work. And when we launched Octane shortly thereafter, we put out something called Octane Bench, which was a way to benchmark your GPUs so you could figure out how, whether to purchase a GPU based on this Octane Bench score. And when we launched our service on AWS, we basically just sold Octane Bench as credits. And we've recently decided to use the very same Octane Bench metric to launch a token-based system on the Ethereum blockchain that you can use to map work done. And I think that you need something like that. We need to go away from like the number of cores, how much memory or nodes to, GPUs are so powerful that if you have 4 of them or 8 of them, or you have 1,000 frames and 1,000 GPUs, you can just easily map that workload on there. And I think that when you're looking at more exotic types of rendering, like light field rendering or holographic rendering, or even really high-end VR rendering, those metrics start to matter a lot. And I think that I think that as we're seeing film work that's being done on the public cloud, which is interesting, I do think that there is an appetite to test, this same process for new media, and that can be, projection map, large-scale events, or VR, or even just preparing for films one day to have not just left and right eye rendered or 3D, but to be holographic, and that is 2 orders of magnitude more than what we have available today in terms of capacity.
Very true. Guys, other things to
Yeah,
add?
I mean, from Redshift's perspective, like we're a pretty small company, so I mean, the challenges for us, I mean, they're definitely not insurmountable, but we have a certain licensing model that, and when we figured out our pricing, we figured, okay, people are going to have this many GPUs, and they're roughly this, 10 or whatever times faster than an equivalently priced sort of CPU rig. And then that's how we came up with our pricing to sort of make it competitive. And what we're seeing now, though, with the cloud is it's like a lot easier to sort of turn that knob up and make your machine really beefy. Whereas, to build a machine on premises that has 8 or more GPUs, you need very esoteric hardware.
fancy motherboards, dual redundant power supplies, all this kind of expensive stuff. So generally our customers weren't doing that. And so we said, okay, we're going to ignore the 2% of customers that are going to build giant machines, and we're just going to charge a flat rate per node. But what we're seeing on the cloud is that, if people are saying, okay, well, instead of spinning up 10 low power machines, I can spin up one high power machine and only use one Redshift license. So that's kind of throwing a little bit of a monkey wrench into our pricing model. But, that's, like I said, it's not insurmountable, something we can address.
Yeah, that's definitely a true thing for us too, on the CPU world as well. But one thing I like about the GPU on the cloud is you can get really nice GPUs, but they're really expensive to buy an actual one, as we heard a little while ago with the V100s. But if you, on the cloud, if one day you need, 60 gigabytes of GPU RAM, well, you can go on the cloud, it's not that painful. I think that makes, that'll make a big difference, because it opens up to, anybody. CPUs, it's not that big of a deal to get a high-powered machine on your desktop, but more challenging for a GPU right now, at least I think.
Yeah. I think one of our largest jobs on AWS was 2,000 GPUs to do an overnight VR render. So availability is, and it was, I can share it was using a lot of, more than one Amazon region, so capacity is a pain point. I think that in some ways we're the victims of our own success because GPUs could be so well, used so efficiently for really high-end render jobs. I think that there's not enough of them, frankly, on the public cloud, even on AWS. We can only service, even with all the GPUs that are available after years, probably only a few customers a day that would be at that maximum. So I think getting more and more GPUs on the public cloud would be great. And I think that'll start to happen as more and more renderers have GPU implementations, and there's just more demand for that.
Very cool. In talking with some of the people during the break, one of the things that I think they'd love to hear from is the optimal scenarios for a studio that's going to make the jump and start working with stuff in a GPU cloud environment. Like, what would be your guidance to them? How do you just jump in and transition from an on-prem to a cloud, a hybrid, and GPU from CPU? And I mean, there's a lot of companies and a few folks I've talked to that have been studios for quite a long time, and they're like, how do we take advantage of this new world? And so I'd love to hear from you guys, like, what things should they be thinking about? What things should they be considering as they start this process?
Well, one easy one is how much memory do you need? And so since we'll have both a GPU and a CPU option, and you can render the same image on both, you can say, oh, wow, this is not really going to work on the GPU setup. Let's run it on the CPU. And, oh, this is fine. We can just use the GPU. So just knowing where that memory cutoff point is, I think, the biggest one. The second one, at least for us, is whether it has all the features you need. On the CPU, you can write C++ shaders that send emails and do whatever you want. I don't think we can send emails through GPUs. So
Not yet.
You're a little bit more constrained on what you can do. So for many customers that won't matter, but for some it will, and that's going to be a motivating factor.
Yeah. We added open shader language. We actually built a little compiler inside of Octane to do open shader language, which I think we're all trying to support, which helps add more flexibility for GPU rendering jobs. And I think that the other thing that we did to make even just access to the cloud, regardless of whether it's GPUs or CPUs, easier is inside of all of our integrated plugins, you can basically take a snapshot of your scene, it packages it up, and sends that basically to AWS, and you can fire and forget, and that really does help. One of the reasons why we did it that way was that rather than setting up a version of C4D with the Octane plugin, all these other plugins, I mean, that's a lot of extra complexity. Licensing C4D on Linux has been challenging, so having the ability to headlessly render your scene without having the host application or even Windows on the cloud is nice. And I think all three of our renders support an export option that you can package up and render with a standalone tool this way.
I mean, yeah, I think that's right. One thing that I think people often worry about, and I think it's a legitimate worry, is I/O to and from the cloud. How do I get all my data up there, and how am I going to get all my frames back? Sometimes these caches and stuff can be pretty massive, and so presumably bandwidth is going to continue to improve dramatically over time. People are maybe going to start building their studios, closer to the fat pipes, but yeah, I think that continues to be a concern for at least for some customers.
I have a data point to add to that, which is throughout all the different, because we manage basically our cloud service for customers, so we have a lot of insight into the amount of data uploaded for scenes versus how much is rendered. And these renders are just EXRs, dpixels sometimes. The EXRs are so much bigger than the uploaded scene data. So I think that no matter what you're doing on the cloud, you have to render this data. So it seems that what we learned, at least from running the cloud service the way we've been doing it, is that the scene data is a trivial amount of bandwidth or data in terms of uploading that versus the data that you have no choice but to download, especially if they're larger EXR renders.
Yeah, a lot of the data going up is all the same per frame. It's all going to be unique on the way down.
Yeah.
What about in the collaboration standpoint, studios working with other studios? There are things that, a non-GPU-based studio that's moving into a production, but they're working with a company that's already in GPU, or, how do the mix and match type of things affect them?
So in our case, if they're using Arnold, it won't matter, because it'll work both the way, CPU or GPU, assuming they're not doing anything crazy on the shader part. So that I don't think will be a problem. I think OSL will be a big help for between us. And so they can use Arnold for, Studio A, and Studio B can use Redshift. Yeah. Wait, do you have OSL?
Not yet.
Or they can use Oculus then. You have OSL.
Yes, we have OSL.
So, but eventually, we'll probably all be on it. So I think that's going to be a big help.
The other thing I think on the GPU is that it's mostly an NVIDIA world. I mean, that probably simplifies things. We've tried everything to get Octane on AMD. We did a CUDA cross-compiler, but it just has turned out that really, basically, CUDA and NVIDIA have really delivered a professional-grade solution for us to build GPU renders, and even then, it's not perfect. Debugging and all these things it's still difficult. But that I think is in some sense creates uniformity. I think even the GPUs mostly on AWS are NVIDIA. I think maybe the G3s aren't, or there's I think the dockable GPUs are AMD, but a lot of people do have the same type of NVIDIA hardware. That's made it easy for on our end to support GPU customers because there is that uniformity, and that's just the way the industry is shaped up over the last few years.
Cool. What do you think is the next big hurdle? And price can't be the answer as far as, because we all know that that's what we'd love to see, but this is more of a wide open question of where do you think the next hurdles are for GPU and what do you think it's going to take to get there?
So mine is the same problem from a decade ago with memory. It's still not enough for, you can do out-of-core, but like you said, you do get a hit. Mm-hmm. And so it'd be nice not to have any hit.
Yeah, I second that. I think having more memory would be great so that you can get maximum speed. I think NVLink's a stepping stone towards that. It's just expensive. So most people that are using GPU rendering locally or on-premise don't necessarily have those expensive cards, but it is on the cloud. I think that advances in, we did, so our denoiser, AI denoiser, we have a CPU fallback. It is 20 times slower. So conversely, having more ASIC, more advanced things you can put in a GPU that may not necessarily go into a CPU could help with denoising and other parts of the rendering pipeline. Those advancements, I think, are going to be coming down the line as well. And capacity. Cloud capacity for GPUs would be great. More of them would be a real help.
Yeah, the only thing I'd add to that is continuing to chip away at the misconception that the GPU is somehow not suitable. To me, that's actually the biggest hurdle.
That's a really good point, and that because that's something I've heard in my travels and things too. Is that's where the trepidation comes in. Mm-hmm. Why do you think that is? Is that do you think they see different render? It's a render is going to be done to what they say, but I'm curious as to why is there a perception that it's something not going to be the same as what they're traditionally.
Well, I think because historically there's been some truth to it. There were some failed GPU renders in the past, like Gelato and stuff like that. When Otoy first came out, it was fairly limited in features compared to the V-Rays and the RenderMans and so on. And so was Redshift at the outset. But with enough elbow grease and hard work and all that, and with advancements of GPUs and the software infrastructure around them, CUDA and the like, that's really, those excuses are going away.
Going away or gone? I mean, like, is there something a CPU can render that a GPU?
I mean, like Tiago said, like you're not going to send an email from your GPU shader, and even more realistically, you're not going to open a file and read things from a GPU shader. There are, writing efficient code for GPU is completely different than writing efficient code for CPU. So there are clearly challenges, and I'm not going to say that every problem is always going to be better solved on the GPU, but in terms of sort of most things, I think the GPU is probably suitable now and certainly in the near future.
Yeah, I think, well, first the email is, a joke.
Yeah.
But a real example is we had customers back in the day when we didn't have volumes, and they implemented a volume integrator inside of Arnold. That would be very challenging to do on a GPU, allowing that kind of programmability without destroying performance. So like that's I think one big issue. The other one is there's a difference between GPU and CPU, and the programs have been written for GPU and CPU. And so, like your software has been getting better every year because you're working on it. Same thing, CPUs are getting better. It's also as people keep writing code. So there is, we have to be careful when we say, CPUs and GPUs, which are better, to not extrapolate, the code versus the hardware.
I'm curious I'd love to know when that moment of that aha moment when you saw something happen on the GPU that made you realize that this is really where it's all going. It's really going to all start to take place from a power standpoint, efficiency standpoint, speed. Was there any one particular production, doesn't have to be even with your own stuff, just a moment in time where that transition lit up and you said, okay, I can see where the future is going?
For me, it was before Octane, long before Octane. I was writing experimental ray tracers in DirectX 9 shader language, for game engines. And I think even your guys' background is from there as well. And so seeing ray tracing on a GPU working in real time, and I have stuff from 10, 11, 12 years ago, videos that came out in TechCrunch showing that. I think that was also when I first met you, when you were at Lucasfilm. Like, that was my aha moment. Wow, we can actually do ray tracing on game graphics cards. So at some point, we'll get it all in there. And I think that, for me, was the first ray tracing that was interactive was my aha moment in the mid-2000s, basically.
Yeah, I mean, I had a sort of similar moment when we were working. At the time, I was at a game company with my other co-founders, and we were just working on Redshift sort of evenings and weekends as a little side project after an artist asked us why our game was running at 60 hertz, but it took 2 hours to render a frame for his character turntable in Mental Ray. And why can't we do this? Use the GPU to make that faster. And we explained to him all the reasons why it's impossible. And then we started thinking about it. Maybe it's not impossible. And we were screwing around also with DirectX 9. Yeah. And we had this. I don't know if it probably wasn't 30 frames per second, but it was probably around 10 frames per second at low resolution, 512 by 512 or something, but an interactive ray traced with reflections and refractions and everything. And I was like, whoa, this is really cool. And looking back, I think we were probably pretty naive as well at the time. We didn't understand the full scope of production rendering and all the complexities. But I think maybe that was a good thing because it didn't scare us off at the beginning, and we sort of dove in head first, and here we are today with making big waves.
Nice.
Yeah, I think for me it's several years ago when we started getting 12 gigabytes on cards. It's like, oh, okay, now it's starting to be something that we can look at, and then combine that with NVIDIA's optics, where it's like, we don't have to invest tons of resources just to get to a certain point, and then have to keep every year putting in those resources to maintain the top performance on the latest GPUs. With optics, we just get it forever, but in theory.
Very cool. I've got a few more minutes here. I'd love to hear some closing thoughts and where you see this going, where you see the opportunity, where if you were driving a studio today, what things would be considering how you'd set up your infrastructure and artists, and kind of more wide open space for you. So why don't we start with you, Tiago?
Oh, that's a hard one.
That
is a hard
finish with
question.
an easy one.
Yeah, I am just really excited to see where it goes. I see people using GPUs and CPUs left and right. Hopefully it'll be to personal taste. What direction it goes, I guess now that we're doing GPUs and CPUs, I don't care anymore. So may the best hardware win.
Do you ever see the point where you'll have just a completely dedicated Arnold for GPU?
You mean getting rid of CPU or
Yeah.
branching into?
Either or.
I would hate to branch. I think one of the cool things is when you can have the same underlying software. So our GPU and our CPU code shares a lot of the same, it is the same code with just a couple little modifications here and there. And I think that gives a lot of power to the user because they can switch, this shot's going to be on the CPU, this shot's going to be on GPU. I would only get rid of one if one is clearly not good anymore. And I don't see that happening in a long time.
Very cool.
Yeah. Well, I think that one of the great things about the way that Octane works is that when you're in the viewport and moving things around, like you're basically seeing the final frame being rendered. And so a lot of artists like Octane because what you see is what you get, and there is no rendering step. And so a lot of artists, of course, have GPUs on their workstations just to run the content authoring tools. So our goal is to make it so that those GPUs, which are probably always going to be there, still can render, and that we can seamlessly bridge more rendering power, whether it's through the cloud or just network rendering, anything else, in a really easy way and in an inexpensive way. And going back to my earlier point, if you just look at the way that even Octane's been used in films, I mean, there's certain shots where there was a movie, the large movie we can't talk about yet, where the only 3D shots that were rendered left and right were in Octane. And you hear sort of rumblings around, like Cameron exploring glasses-free 3D. I think that holographic screens are just going to be, a really simple and obvious, endpoint for media and for rendering. And I think that GPUs and the order of magnitude increase in speed, at least that we're seeing, on that is going to be a big part of why people leverage them for this kind of future holographic experiences and media that we think is coming in the next decade.
Very cool.
I mean, from my end, I'm just really excited to be, in this space, to have peers like these guys here. It's to be sort of competing with all these smart people to sort of just try to give artists the best tools that they can have to make their amazing work. That's what keeps me going, and that's as long as that keeps happening, we're going to keep trying to make it better. Hopefully that's with the GPU, but if something else comes along that's better, we'll go with that too.
Very cool. I think one of the always interesting things that I like to hear from artists on especially is that the more you give them, the more they'll use. And so just the fact that you get these more powerful GPUs and more access to stuff in the cloud and stuff, doesn't mean that they're going to do stuff faster. It just means they're going to do more stuff. And I think it's always interesting to see what more can they do? What things have they not done yet? Render an entire film interactively or something like that. When are we going to see those types of things happen? So I don't know. That's kind of my closing thoughts in a sense. And I would just like to acknowledge our sincere thanks for these gentlemen to be here. I mean, we are, each of these companies are in the throes of SIGGRAPH coming up, and probably you guys probably know the hours to get to SIGGRAPH, and they cut time out of their day to come and be here with us, and I'm very grateful for that. I thank you guys very, very much. Also, I want to make sure to thank our sponsors that have been here and so helpful for making this happen. And also not to forget that there is a reception, a networking reception that's going to be taking place from 4 to 6. You can see these gentlemen if they're still going to be here. They may run off to get their SIGGRAPH stuff done, but if you have any further questions and stuff, feel free to grab them and ask questions. Thank you very much. Thank you, guys.